So yesterday we started with these word problems, and we're just going to practice through more of them. Really, we're just dealing with sine and cosine, and just look, read the word problems and see if we can identify these things such as amplitude, period, phase shift, and vertical shift. But getting used to using these words to help us create this picture of the graph. Okay, so if you guys can turn to page 32. Now, before we start, yeah, okay, so sometimes they tell you what the function is, and that kind of helps. Other times when they don't tell you the function, it's always good to go back and think about what the parent graph of the sine and cosine looks like, and use that to help us decide certain things. So let's read number 1 here. A certain person's blood pressure oscillates between 140 and 180. If the heart beats once every second, write the sine function that models the person's blood pressure. So oscillating between 180 and 140, that's going to be the what of the sine graph. Yeah, the min and max, right? So if I know the min and max, I can use that to help find the what? The midline. Yep, the midline is exactly between the max and min, right? Everything is going to be nicely symmetrical that way. Okay. So next, if the heartbeat once every second, so think of a heartbeat as 1 cycle, and so therefore 1 cycle is 1 period. So period equals 1. Okay. Just reading. So period is equal to 1. Okay. Write a function that models the person's blood pressure. Okay, so from this t equals 1 second, we can find our b value. Oh, my bad, my bad. Period is 1, right? Okay. Yeah, I messed up. Sorry. So period is 1 second. So 1 is equal to 2 pi over b. Cross multiply. Sorry about that. I replaced 1 for b instead of for period. Okay, so b equals 2 pi. So we know it's a sine function. So for the sine function, we know that we want to start at the midline. And then from the midline, it's going to hit its peak. It oscillates between the max and min. Okay, so we know the max as well. Max is 140. The min is is 80. Okay, so from this picture alone, can we figure out what the D value is? 1/10, right? So we can also do this. We can also add the two numbers together and divide by 2 to find that average, or can you kind of just figure out by counting? So P equals 1/10. Okay. Now, what's the amplitude? What's the A value going to be? Yep. It's the distance from the midline to the max, but you can also go from the midline to the minimum. Either way, it should be the same distance. Okay. And they say it's a sine function, right? So there's no what's our C value? Any shift? No shift, right? They're not telling us that there's any shift, and they're telling us to use the sine function. So okay, so we can write our sine equation. Sorry, plus 110. Okay, number 2. Yes, that's right. You can use x, you can use theta, you can use whatever variable you want. Yeah, that's fine. You can choose whichever, or sometimes I use t for time. So you have a lot of variations you can choose for whichever variable you want to use. Okay. All right, so number 2, I'll put this on a separate sheet just so I can have enough room here. A rodeo performer spins a lasso in a circle perpendicular to the ground. The height of the knot from the ground is modeled by h. Where t is the time measured in seconds. What is the highest point reached by the knot? What is the lowest point reached by the knot? So all we need is to look at the A and the D value, right? So we'll worry about the period and all that later, but we can kind of just do a quick sketch of the graph. My midline is 3.5. So if I take my A value into account, what's going to be my highest point? Yep. And what's going to be my lowest point? And we know that because we know the distance from the midline to the peak and the valley, or peak and minimum, is going to be a distance away, right? And the negative just means it's a reflection, which is going to impact the shape of the graph, but it's not going to impact the distance, right? So 3.5 plus 3 is 6.5. 0.5 plus 30 is 3.5. What is the period of the model? Well, we have our b value, and we can just use our b value to find our period, right?
There's points if we don't do the graph.
No, Unless I specify to draw the graph, but right now I'm just doing it visually to help me. But yeah, this problem does not ask us to do anything with the graph. So it's not, if direction doesn't say to draw the graph, then you're not gonna be required to. Okay, dividing by fraction, the same thing as multiplying by its reciprocal. So I can make it 3/5 pi. Pi's cancel out. I get 6/5. The time period is seconds. So that's also 1.2 seconds. Okay, part D, according to the model. So here's our model. Find the height of the knot after 25 seconds. So what do you think we can do? Yeah, 25 and 50. Make sure that you're in radian mode because the 5 pi over 3 is for radians. But that h of 25 just means I'm about to insert 25 into my equation. Okay, double check you're in radian mode. Start entering this in. Okay, we're doing the same things that we've been doing from the previous before word problems, right? But it just feels a little bit different because we have to interpret these sentences and these scenarios into sine and cosine function. But then once you can, pull information from what the graph is or what the problem is saying, then really it feels very familiar, right? Things you already know how to do. Okay. Okay, let's read number 3. Does anybody still need to look at number 2? All right, let's look at number 3. Number 3 says part of a roller coaster track is a sinusoidal function. So this is basically, it's not giving it away, right? It could be either a sine or a cosine. Okay, but we want to choose the one that is easier to model after. Okay, so right now it's not committing to either one or the other. It's either sine or cosine. The high and low points are separated by 150 feet horizontally. Okay, so the peak and valley is separated by 150 feet. And 82 feet vertically as shown. The low point is 6 feet above ground. So it's kind of like the problem that we did yesterday, where the amusement ride, the Ferris wheel was above ground. Okay, same thing here. The lowest point is 6 feet above ground. Write a sinusoidal function that models the distance the roller coaster track is above ground at a given horizontal distance. Okay, so we're basically just going to create this equation, trying to find all the information that we can: the A value, the B value, the C value, and D value. Okay, so we'll take it step by step. Now, look at this here. What does that resemble to you? Cosine or sine? Cosine, because it starts at the peak, right? Okay, so if you look at the cosine graph, right? Peak to midline, to minimum, to midline, to peak. Now, from peak to minimum, how much of the period has been achieved? Half. Okay, so that 150 is not telling you, but you're looking at that, understanding that if I go from peak to minimum, I'm halfway through my period. So I can use that to help me get to my period. Therefore, my period is going to be what? 300 feet, right? 150 plus 150 equals 300. Okay, good. Next up, we have our minimum, right? Our minimum is what? 6. Okay. What's our maximum going to be? Because you added what? 82 to 6, right? So the minimum plus your entire distance will get you to your maximum. So therefore, your maximum is 88. Okay. Now, can I also find my midline? Okay. It's the average of those two numbers, right? So add the two numbers divided by 2. What's your midline going to be? 47. Yeah, so I can do 88 plus 6 is 94. 94 divided by 2 is 47. Okay, so just to kind of give me some visual perspective here. So we can also find the A value, right? How can I find the A value? Good. Maximum minus the D value, midline. You can also do midline minus the minimum. You should get the same value. So 88 minus 47. A is 41. Okay. Do we need to adjust this? Should this be a negative? Is our cosine being reflected? It's not, right? It's starting at the peak. Now, if it started at the lowest point, then we got to worry about that A value being reflected. But this is where the cosine begins, right? The cosine begins at the peak. It makes its way down, okay? So the only thing left is to figure out the B value. Well, what's our period again? 300, okay. All right, so find your B value and everything should be ready to go. Okay, what's also C value? Do we have a C value? C is just what? 0, right? Because we have a nice cosine function that's starting where it's supposed to start, no shifting. So find your B value and you create your equation. How to find a D value? Okay, so the D value we know is between 6 and 88, right? Because the lowest point is 6 plus 82 will reach us to the maximum. So my maximum is 88. So you're good with the 6 and 88. Okay, so the midline is going to be halfway between the minimum and the maximum. And the way I can find the average of those two numbers, I just add them and divide by 2. Yeah. I can add the max and min divided by 2. That will get you to your midline. Yeah. So if you want to use this formula, you can. Or you can think of it as just the average of two numbers. Minus max plus min divided by 2. I use text. Doesn't. I'm leaving the C out of it. That C is 0, so it's not going to impact anything. And finally, plus. So x represents any distance along the cosine graph. And then if I plug in an x, I can also find the height. So it says point A is 40 feet to the right of the y-axis. How far above ground is the track at point A? Well, this formula is now designed to tell us the height at any moment in time for this roller coaster. So I can just insert 40 in for x, find the height. Again, radian mode because of the pi. Practice entering into the calculator. Make sure you're getting, make sure you know how to enter this in so that you can do this on the quiz.
Do you always round the 3 decimal places?
It doesn't specify. So if it doesn't specify, you can kind of decide how you want to do it. On the quiz, I will specify. If I want a certain decimal, I will specify what decimal. Okay, a buoy bobbing up and down in the water as waves pass it moves from its highest to its lowest point and back to its highest point every 10 seconds. The distance between its highest and lowest point is 3 feet. Determine the amplitude period of a sinusoidal function that models this bobbing buoy. Okay, so let's think of sea level as 0. So if it was still water, then our D is 0. And it says highest point to the lowest point and back up to the highest point. So what's this? What is this describing here? In terms of either sine or cosine. Highest to lowest and back to the highest. That's cosine, right? So I think it's it kind of makes sense for us to kind of think in terms of cosine. So peak, midline, minimum, midline, peak. Okay, the distance between its highest and lowest point is 3 feet. So we know that from here to here is 3 feet. And we're going to treat the, if there was no waves at all and the buoy was not bobbing up and down, we'll consider that as sea level. Okay, so we're going to let D be 0 because sea level is exactly basically ground level. Okay, but it's going to bob up and down. So what's the highest that this buoy is going to be? 1.5, right? Okay. What's the lowest that it's going to be? I know. Okay, let's double check that. How do we know that it was going to be 1.5 and negative 1.5? How did you come up with those numbers? Yeah, because the distance from negative 1.5 to 1.5 is 3, right? From negative 1.5 to 0, that's 1.5. Another one from 0 to 1.5, another 1.5. We add those together. That's a total movement of 3 feet. Okay, what's our period? Yeah. So we should have enough to write the cosine function for part B. Oh, what's our A value? 1.5. Okay. All right, so see if you can do part B. Use your period formula to solve for B. So it says using x equals 0 at its highest point. So they want you to start at the highest point. So basically telling you to use cosine. That's what this means. Okay, so give that a try, and I'll follow up with the steps. Yeah, you can leave that plus 0 out. We don't need that, actually.
I didn't know you use cosine basis just like x equals 0.
It says that x equals 0 is the highest point. So that means when it begins, it's going to be at the highest point. And that kind of clues us in that we're not starting at the midline. Right? If we start at the highest point, it just makes more sense to match it with cosine. Okay, next page.
And the b equals negative 1.5 is the highest point of the 0.
So x equals 0. X equals 0 is here. So it says that when x equals 0, this is 0, 1, 2, 3, 4, 5. Right? X equals 0 is starting at the peak. So if it's starting at the peak, then we can kind of use that to help us, narrow down that the cosine will be, it matches the cosine behavior better. Right? Okay, page 33. Okay, the average monthly temperature for Baltimore, Maryland is shown. Determine the amplitude, period, phase shift, and vertical shift of a sinusoidal function that models the monthly temperature using x equals 1. Okay, so we're starting at 32, and it continues to rise until it hits, sorry. Okay, so we look at this data here. We're starting with January. This is x equals 1. And 32, 35, 44 continues rising. And then where's the peak? 77. Okay. And then it's going to make its way down to 37. And we're just going to think of this as the end of the period. I know it's not perfect. There are 37 and 32, but we're just going to create a model just based off of that 12-month period. Okay. Okay, so we can kind of understand that we are starting at the lowest point here. Right, so let me call this 32. And we're going all the way up to 77. So we don't have to fill in all the details. We kind of just have an idea how the graph is going to look. Start, midline, peak, midline. Right, it's going to look something like this. All right, just to kind of get the broad strokes, right? Now, what does that graph look like to you? More like a cosine or a sine? Now, it starts at the minimum, right? Now, if it started at the midline, then we would say it's more sine, right? But if it's starting at the minimum, it's more like cosine, except what? Reflected, yeah. So instead of a right side up cup, it's an upside down cup. So resembles more like cosine. Okay, so now from here, what information can we find? Midline, yeah. And again, the midline is just averaging the max and the min. So I can add 32 plus 77 divided by 2 and find the average between those two numbers. What's our midline? Okay. From this, we can find our A value, right? Subtract max minus the midline. Okay. Yep, 22.5. Oh, I made a mistake here. It says using x equals 1 to represent January. Okay, so this graph is more like this here. Starts here. So instead of starting at 0, it's starting at 1. So therefore, there's a what? A phase shift, right? So our C is going to be in the equation. They'll go in as a negative 1. Okay. But what's our period going to be? So we're starting at January, ending at December. So we do what? 12 minus 1. Find our V value. Okay, so we're still going to target cosine, but we know it's reflected, it's been shifted. So we have our A, B, and C and V values. Let me list them all out. Yes.
Isn't that period 12 minus 1?
Because the period is going to be the distance from the beginning month to the end month. So we do 12 minus 1. So 12 minus 1 is 11. Now, if we start at 0, then we will do 12 minus 0. Here, we're representing 1 as January.
We should keep the graph left or right.
We're shifting it to the right, the minus. Okay, so plug 7 into the function and plug 12 into the function, and we can find the temperature and in those months. This model is not perfect because we're ending at 37, but we're just getting some approximations here. Okay, I want you guys to read number 6 and see if you're able to create what the graph could look like. And, kind of go through this, because we know it's either sine or cosine, so we're just kind of grading it and using context clues to help us decide how the graph will look. Okay, so go ahead and read number 6, and I'll follow up with the steps. Okay, that 322 million is not going to factor into any of our equation. Hardest part is just to create the graph, right? So the surface is going to start at equilibrium, right? The surface will be, we consider 0, right? But then after that force occurs, the surface is going to move down from its normal position. So we know it's going to be down to the minimum first. Okay? And we know it's going to go back up to equilibrium, and then it'll hit a max and then back down. Now it says at 300 milliseconds, it has moved up an equal distance above its normal position. That means we've hit the max, right? So we hit the max at 300. So I went ahead and I just put a 300 there. The total difference in the position is 6 millimeters. If equilibrium is 0, then what's the highest and lowest that this surface is going to be?
6 millimeters.
Yeah, 6 is total, so the highest is going to be what? 3. Lowest is -3. Right? So it's going to be a little bit below the what we consider normal position. And if we know that it takes kind of 3 tick marks to get to 300, we can kind of guess what the others are, right? What's the period going to be then? Well, let's see here. Each of this, if I increment by how, well, what do you think my interval is going to be? Because this is not one period, right? This is not, right? I haven't reached, it's not peak to peak. This is from midline. So from midline, I got to go to midline to get a full period. So it ends up being a nice number here, just 100. So 100, 200, 300. Therefore, period is what? 400. So now it gets easier, right? Now we can find use of period to find the b value. We can find the a value. Oh, is this the normal sine graph? Being reflected, right? Because normally sine goes up and then down. But here it goes down and up, so we know it's reflected. You know your a value is going to be a negative. Okay, see if we can finish this problem here. Part F, if the wave were to continue, predict the vertical position of the Earth 3.25 seconds after our jump. So to get the milliseconds, I need to multiply by 1,000. So plug 3250 in for T. Make sure you're in radian mode. Okay, any questions? All right, so we're gonna continue building this tomorrow. Don't forget your phones. We'll do day 3 tomorrow.